All right. Absolute value. Maybe haven't seen those since Algebra 1 class. So we always, are going to solve the equation kind of without the absolute value. But then we have to think that absolute value actually you can put both a positive number inside the absolute value and get 6, and a negative number inside the absolute value and get 6. If 15 minus 3x is equal to positive 6, I have a solution for this equation. But if this inside the absolute value is equal to negative 6, take the absolute value of that, I still get positive 6. So I have a solution to the equation. So I solve two equations. We never have any problem writing out the equation with the positive. But we also need to do a second equation. And when 15 minus 3x is equal to negative 6, we also have a true equation here. So we solve two equations. First equation, I think I'll just subtract 15 from both sides of the equal sign and get negative 3x is equal to negative 9. Divide by 3, negative 3, sorry. And get x equals 3 as one of my solutions. And you, of course, do the same steps on the other equation that you solve. You just get, a little bit different answer as you work through. So I still subtract 15 from both sides of the equal sign and get negative 3x. This time equals negative 21. Still divide both sides by negative 3. And get x equals 7. Two answers are true. Occasionally, one answer will be true, and occasionally no answers will be true. Yes? Yes. You have to have two answers. You have to solve for two answers. Occasionally, you will just get one will be right, but you have to solve for both of them. Okay? It's not any way, in any form, correct to just solve this as if the absolute value wasn't there, because there's a reason that the absolute value is there. Okay? Come on. You can do this. Go to the next page. Or not. Okay. So this one doesn't look too different than the previous one, but it looks like there's a few more steps going on here. So what I want to do with my absolute value, the easiest thing that I want to do with my absolute value is try to isolate the absolute value to one side of the equal sign, get everything else on the other side of the equal sign, and then try to solve as we did before. So I think with this one, first thing I'll do is I'll subtract the 4 from both sides of the equal sign. And I get negative 2 times the absolute value of x plus 9 equals negative 9. Okay. I will get the negative 2 away from the absolute value by subtracting or dividing? Yes, dividing. Why dividing? Because that's a multiplication right there. The opposite of multiplying, the inverse of multiplying is dividing. So now we divide both sides of this equation by negative 2. the negative 2's go away, and I get the absolute value of x plus 9 is equal to 4.5. All right. Now, if I had a negative number over here, I'd stop and say no solution. But I don't have a positive number. It's a fraction. I can, still have a fraction answer. And now I solve two equations. What are the two equations I need to solve? X plus 9 equals 4.5. And what's the other one? X plus 9 equals negative 4.5. Okay, I don't really care that Norton is performing background tests. So, we'll move on. Subtract 9 from both sides of the equal sign, and I get x is negative 4.5. Subtract 9, and I get x is negative 13.5. And there are my two answers. Okay. And then hopefully, maybe I just need to hit that. Let's see if it'll go to the next page correctly this time. Just doesn't want to. I'll make it. Alright, so now I have one to solve that says I have to check for extraneous solutions. And you'll know you need to check for extraneous solutions, and I'll show you. Extraneous solutions means that algebraically you're going to get two answers for this, but one or both of them might not work if you put the numbers back in and check and see if they work out in the original problem. And you'll know you need to check for extraneous solutions when you have an absolute value problem that also has some x's not in the absolute value. Okay, so that's when you really have to go looking to see if you have some solutions that don't actually work. Those are extraneous solutions. So here we go. So I've got my absolute value isolated on one side of the equal sign, so that's good. So I'll go ahead with my trick of splitting this off into two equations. The first equation, the easy one, 3x minus 4 equals negative 4x minus 1. That one's good. Okay, my other equation that I'm going to solve is 3x minus 4. We had to do negative and positive 6 on the first one, so we do the opposite of negative 4x minus 1. So this is equal to the opposite of negative 4x minus 1. There's your positive, there's your negative. We'll work to the positive one first because that one will be easy. I think I'll add 4x to both sides of this equation and get 7x minus 4 equals negative 1. Add 4 to both sides of this equation and get 7x equals 3, and x equals 3/7. Okay. We're going to have to go back and check that one. That's not going to be pretty since we're dealing with a fraction, but we can do it. I know we can do it. All right, now we'll solve the opposite. So I have 3x minus 4 equals opposite of negative 4x. Oh, that's positive 4x.